Image formation in the case of mirrors. All the rays parallel to the principal axis will pass through the focus of the mirror and similarly the ray coming from the focus becomes parallel to the principal axis after the reflection from the mirror. This is shown here. This is the ray parallel to the principal axis after reflection pass through focus, and ray coming from the through the focus becomes parallel to the principal axis. One ray will pass through the center of curvature, which remains normal to the mirror and can retrace its path. The intersection of these two rays forms the image of the object. Now refraction. When the light rays passes through one medium to another medium, the deviation in the path is observed. The phenomenon is known as refraction of light. Due to refraction, the frequency and phase of the refracted light remains same as the incident light. Second, the velocity and the wavelength of the refracted light will be different from the incident light. Third, the law of refraction remains valid in this situation. The incident ray, the refracted ray, and the normal to the separating layer all will lie in the same plane. When ray passes from rare to denser medium, it bends toward the normal. And similarly, when the ray passes from denser to rarer medium, it bends away from the normal. The product of the refractive index of the medium and sine of the angle between the ray and the normal remains constant, which is known as Snell's law. That is mu sine theta equals to constant for any medium. This implies mu1 sine equals to mu2 sine r. Now verification of Snell's law. Here a ray is passing from one medium to another medium. The upper medium is of refractive index mu1 and the lower medium is of refractive index mu2. This is the incident ray, this is the refracted ray, this is the angle of incidence, and this is the angle of refraction. Now let this distance is x, and this distance will be a minus x because this distance is a. The ray is incident and refracted ray is shown by PQ, QR. From Fermat principle, we know that a light will travel from one point to another point in the least possible time. Now let time travel to P to Q is TPQ and Q to R is TQR. Then total time T equals to TPQ plus TQR. Now time can be calculated because from P to Q light ray move with velocity c1, and from Q to R light move with velocity cr. Then time t pq will be pq divided by c1. So TPQ will be PQ, and now the value of PQ will be this distance is x and this distance is b. This distance is b from P to here, and from this distance is d. So under root b square plus x square by c1, and TQR will be similarly under root this distance divided by velocity c2. So this distance will be, because this is d square, so under root d square, and this distance ka whole square, under root d square plus a minus x to the whole square divided by c2. Now from the Fermat principle that for time to be minimum dt by dx should be 0. This implies differentiating. This will give after differentiation with respect to x, the value will come out to be 2x by divided by 2 under root b square plus x square by c1 minus 2 into a minus ax 2 c2 under root d square plus a minus x whole square equals to 0. Now this implies x by under root b square plus x square, because 2 cancel here and here also, into 1 by c1 equals to a minus x by c2 into under root d square plus a minus x square. This gives uh, this is equal to x by root under b square plus x square is equal to sin I. See here, see it. In this angle sin I equals to perpendicular, that is x by pq, and the value of pq is under root x square and plus this distance b square. So here it is written x by under root b square plus x square is equal to sin I. So we have put sin I divided by c1. Similarly in this, if see here, that is sin r, then this distance divided by pqr will be the sin r. So a minus x under root d square plus a minus x square is equal to sin r. So sin r by c2. So from it we see that sin I, this implies sin I by sin r equals to c1 by c2 equals to me2 by me1, because me proportional to inversely proportional to c, that is me proportional to 1 by c. So c1 by c2 will be me2 by me1. From this we get me1 sin I equals to me2 sin r proved. So this is the proof for Snell's law, that is verification of Snell's law. Now refractive index. Refractive index, it is the property of any medium which indicates the bending ability of the light, and it depends upon the electric and magnetic nature of the media. It is defined as the ratio of the velocity of light in media. That is refracting index of one medium relative to other medium is defined as the ratio of velocity of light in second medium to the velocity of light in first medium. That is 2 me1 equals to refractive index of 1 with respect to 2 equals to me1 by me2 equals to c2 by c1. Or this implies me1 c1 equals to me2 c2, or this implies me proportional to 1 by c. When the refractive index of any medium is measured with respect to a vacuum, it is known as the absolute refractive index. And similarly, when the refractive index of any medium is measured with respect to another media, it is known as refractive index, simply refractive index of that medium. Refractive index of one medium with respect to another medium is defined as the ratio of refractive indexes of two media. The refractive index of the medium absolute is defined as the ratio of the velocity of light in the vacuum to the velocity of light in the medium. That is refractive index equals to c naught by c, or equals to 1 by under root mu naught into epsilon naught divided by 1 by root into mu into epsilon, or refractive index under root mu into epsilon divided by mu naught into epsilon equals to under root mu naught epsilon naught mu r epsilon r divided by mu naught into c naught equals to under root mu r into epsilon r, where mu naught is the permittivity of vacuum, epsilon naught is the permittivity of vacuum, and Permeability, mu naught is the permeability of vacuum, epsilon naught is the permittivity of vacuum, mu is the permeability of any medium, epsilon is the permittivity of the medium, and mu r is the relative permeability of medium, that is mu by mu naught, and epsilon r is the relative permittivity, that is epsilon by epsilon naught, where mu naught equal to 4 pi 10 to the power minus 7 Henry per meter, and epsilon naught 8.85 into 10 to the power minus 12 Farad per meter. The refracting index remains sensitive to color of light, that is refractive index depends upon the wavelength of light and is given by Cauchy equation, mu lambda equals to a plus b by lambda square. This is the Cauchy relation. Now deviation due to refraction. Here it is the incident light and it is intruding from one medium to another medium, so it is deviated. Now the original path of light is this, and but the now after entering the medium the light goes in this direction, so this will be the deviation, angle of deviation. Now because this is angle I, so this angle also will be I due to vertically opposite angle, and this is R, so delta will be I minus R. Here delta equals to I minus R, or delta equals to R minus I, both cases. This is the case, this relation is for when light goes from rarer to denser medium, and this is the relation for when light goes from denser to rare medium. So we can write delta equals to mode of I minus R. This will give the deviation in modulus form, that is positive form. Now calculation of lateral displacement. If a light passes through a medium and again emerges from the same medium, then there is a shift in its path, and that shift, the length of that shift is called lateral displacement. Here this is the, for example, consider this is a medium of refractive index mu1, and this is the another medium of refractive index mu2, and again it comes out in the same medium light. Now the path of light is like this. From in the first medium it travels like this, and then entering in the second medium it travels like this, and then comes out from that medium in the same medium it travels like this. So after coming out of the second medium, the light again becomes parallel to the original incident light path, but the distance between these two line is called, that is distance between emergent ray and the original path of incident ray is called lateral shift. And now we can lateral displacement or lateral shift can be calculated by using formula. Here QR, we have to calculate QR, this is perpendicular, so we can write from sines rule, sin I minus R equals to QR by PQ. So PQ will be equal to, so QR will be equal to PQ sin I minus R, or if the thickness of this medium is T, then PQ is the thickness of this medium, that is PQ. Now from this triangle, if we want to calculate the value of PQ, then from in triangle PSQ, uh, sine R will be equal to this distance, that is this length SQ, divided by PQ. So PQ will be equal to here cos R. Cos R equals to PQ by PS by PQ. आधार मतलब हाँ PS by PQ. Cos R is equal to PS by PQ. So PQ will be uh, PQ will be PS, that is T by cos R, or uh, T by cos R. So here